You ever wonder what the digital world is actually made of? I mean, deep down, it's not magic. Not really. It's something way simpler and honestly way more incredible. It's a universal language that has only 2 letters, and it runs absolutely everything.
I mean, think about it for a second. Every single photo you've ever snapped on your phone, every picture you've stored in the cloud, and yup, every text message, every single email, every one of those late-night chats you've ever had. And of course, every app you scroll through, whether it's for fun or for work, all of it, the whole shebang, it all just boils down to 2 simple numbers. That sounds crazy, right? How can the entire, colorful, complicated world that lives inside our screens be built on something so basic? Well, believe it or not, it is. And that's exactly the code we're going to crack in this explainer. Welcome to the world of binary code. This is a secret language that powers every single digital device you've ever touched. So let's pull back the curtain and see how this thing actually works. You know, the reason we use this 2-number system isn't some abstract math theory. It's actually super physical. It all comes down to the most basic command you can possibly give a machine. Is it on or is it off? Okay, so the official name for this is the binary system. It's a base 2 system, which is just a fancy way of saying it only has 2 digits to play with, 0 and 1. And each of those digits, we call it a bit. And this, right here, this is the key to everything. Just think of a simple light switch. When it's off, there's no electricity flowing. That's a 0. You flip it on, the light comes on, electricity is flowing, that's a 1. Now just imagine billions of microscopic little light switches, we call them transistors, flipping on and off millions of times every single second. That's your computer. So you can see there's a big difference between how we think and how computers think. We use a base 10 or decimal system, 0 through 9, probably because we have 10 fingers, right? But for a computer that just needs a simple yes or no, on or off, a base 2 system is just the most straightforward, reliable way to get things done.
All right, so we get why computers use binary, but how do they use it to represent, actual stuff? Let's try to learn a little bit of their language. It's all about recognizing some simple patterns, don't worry. Okay, let's translate this binary number, 1011. We're going to work from right to left. So that first 1 on the far right, that's in the first position, so it represents 2 to the power of 0, which is just 1. The next number is another 1. That's in the second spot, so that's 2 to the power of 1, which is 2. Next up is a 0, so its value is, 0. And that last 1 on the far left, it's in the 4th position, so that's 2 to the power of 3, which is 8. Now we just add them all up. 8 plus 0 plus 2 plus 1 gives us
11! See? Not so bad, right? It's just a pattern. Every single combination of 1s and 0s translates perfectly into a number that we can understand. It's a simple, brilliant system of translation.
And we can go the other way too. Let's take the number 13. To turn it into binary, you just keep dividing by 2 and writing down the remainder. So 13 divided by 2 is 6, with a remainder of 1. Okay, now take the 6. 6 divided by 2 is 3, with a remainder of 0. You just keep going like that till you hit 0. Then, and here's the trick, you read those remainders from the bottom to the top, and that gives us 1101.
Okay, so numbers make sense. But what about, everything else in our digital lives? This is where binary stops being just a cool math trick and becomes the absolute foundation of our modern world. Because with those simple building blocks, you can represent literally anything. We just decided, as a group, to assign a unique binary code to every letter, to every color pixel in a photo, to every little piece of a sound wave, to every command a program needs to run. We translated our whole world into a language the machines can process.
And this right here is the big aha moment. When you type the letter A on your keyboard, your computer doesn't see an A. It sees this pattern, 01000001. There's a different code for B and another for a question mark. That text message you sent this morning, it was just a massive, super long string of codes just like this one.
So let's just zoom all the way back out for a second. This isn't just some technical trivia. This is the invisible architecture that our modern lives are built on. It's the code that's running in the background all day, every day, whether we see it or not.
So really, when you get down to it, binary is the native language of machines. It's simple, it's reliable, it's based on a physical state of on or off. And decimal, that's our language. It's intuitive for a species with 10 fingers. They're just 2 different languages for 2 very different ways of processing the world.
And that machine language, It is everywhere. From the router that's sending this data to you right now, to the phone or computer you're watching on, even the little microcontrollers in your car or your TV, they are all constantly talking, processing, and thinking in these long, long streams of ones and zeros.
So when you really stop and think about it, our entire complex, amazing digital universe was built on the simplest possible difference, on or off, 1 or 0, which leads to a really interesting final thought. If we've managed to build all this with just 2 states, what becomes possible when we start building a world with more? What does that future even look like?